Guys, today I want to go through stretching, shrinking, and reflecting on these graphs. You saw the code yesterday for these graphs. It's parental graphs, parent graphs. The linear was straight, f of x equals x. Exponential, if we had growth, it was 2 to the x. Decay, it was 1/2 to the x. They curved up or they curved down. Absolute value lines, and it created a V shape. Quadratic has x squared and creates the u. Now go back to your notes yesterday or view that other video if you're a little bit lost on that. We also talked about this code like a phone number. Different numbers in different positions create things. Yesterday we worked on the k value causing a graph to actually go up or down, or the h value causing it to go left or right. Today, get this down, we're going to look at the plus minus in front. The minus causes a graph to flip. The a value, if you just think of it as an absolute value, if it's between 0 and 1, it'll shrink it. It'll shrink it right down like that. If it's normal, that's just 1. It'll look like the parent function. If it's stretched, it means that that a value is greater than 1. It's pulling it up off the x-axis like taffy. Okay? So, here's our codes. So, a stretch, let me give you an example. If we had y equals 5 absolute value x, that stretch would create this. On the graph, the parent function looked like this. 0, the absolute value of 1 is 1. Absolute value of 2 is 2. So the parent function looks like that. Now let's look at the stretch. What occurs is that we get the absolute value of 1 is 1, but then we have to multiply it by 5. So it stretches it. The reason we call that a stretch is that we're looking at the distance between the graph and the x-axis. The same location that's stretched at that 1, it's a stretch there. Okay? So anytime, whatever shape of graph we have, if that number in the front is bigger than 1, it will stretch it. That will stretch it away from the x-axis. Okay? On a shrink, well, it would do the opposite thing. Let's look at, I'll use the absolute value again. It's so clear on it. So, but it will work on any of these. So if we have a 1/2 absolute value x, now that should create a shrink. We go there, our parent function, absolute value of 1 was 1, so it goes like that. Now, if we plug in these values, the absolute value of 0, 0, 0 times 1/2 is 0, so it still goes through the vertex. Doesn't shift left or right because we don't have a k or an h value. But now, the absolute value of 1 is 1, but then we have to multiply it by 1/2, so it comes out like this. Absolute value of 2 is 2, but 1/2 of that is 1. So our new function looks like this. We say it's a shrink because the distance from the x-axis to the graph line is less than it was with the parent function. And it will work the same if we have y equals 1/2, 2 to the x. Well, now you should think about your sequences. That 1/2 told us that's where we started. Our parent function, remember on a exponential, actually goes through at 1 and it increases. But if we have a 1/2, that's saying that our first, or our 0th term, I should say, not first term because we're not in a sequence, we're in a function rule. I hope you caught that on me. Function rule, the 0th term would be a 1/2, so it's just lowering it down here, shrinking it. And it will actually shrink every value. Okay? So, because it's taking 1/2 of whatever they are. So now on the reflect, the only thing that causes a reflect is if we take the parent function. You could have an a value up there too, it won't matter. But you put a negative there. Now think about this. The parent function was absolute value of 0, 0. Absolute value of 1 is 1. Absolute value of negative 1 is 1. So it's like this. But now, here's the new function. absolute value is 0, 0. That doesn't move. We haven't shifted left or right. But when we plug in 1, absolute value of 1 is 1 times a negative. So it comes down like this. It flips it, it reflects it over the x. That's why I wrote reflect like that. It goes upside down on the graph. Anytime we do the negative, it will do a flip upside down. So when you come into class and I'm holding up the board asking you to move in the direction I say, make sure that you have this in your notes. And remember that when we plug in the negative h to go left, that negative and that negative make it look like a plus. So if you see a plus h, it actually means left, because you're plugging in a negative h. If you see a minus h, then you've plugged in the positive h, and it's still got the minus from the formula, and that will go right. So I will be writing things up, and you'll be either graphing or moving your body. So study this, make sure you get it down. It works on every graph.